Good day, all. So today we're going to talk about special angles formed by transversals. Now, our goal of today's video is to get you to understand the parallel lines cut by transversals, the angles that they form, and then to be able to find angle measures using those special angles. We're also going to tie this into algebra to find unknown variables and angle measures involving those parallel lines and the special angles that transversals cause. And then in addition to that, we want to be able to look at parallel lines that don't have their transversals complete. So we're going to complete them with what we call an auxiliary line. Okay? So let's jump right on in to parallel lines cut by by transversals and the special angles they create. Now, what I want you to understand is that transversals also can cut other lines that are not parallel. But when the lines are not parallel, the special angles that they form are not congruent. So for this particular video, we're going to assume that our lines are parallel so that our angles are all going to be congruent. So let's begin. So in our example, we have line M and line N, and they're cut by transversal P. We know that M and N are parallel because each one of our lines has a little arrow on it, and those arrows tell us that the lines are parallel. Okay? So the very first angle we're going to talk about is our corresponding angles. Well, corresponding angles are angles that are in exactly the same position on each one of their lines. So on their respective lines, I want to look at their position. Are they on top of the line or are they below the line? And then we want to make sure they're on the same side of the transversal. Are they left side of the transversal or on the right side of the transversal? Okay, so let me show you what I mean. So let's look at angle 2 right now. Angle 2 is on top of line M and to the right of transversal P. So I want to go down to line N and I want to find an angle that sits on top of N and to the right of the transversal. And that angle is 2. So we know that angle 2 and angle 6 are corresponding angles. Okay? So why don't you pause the video now and see if you can find the other angles that are corresponding. Hopefully you stopped the video and you were able to find the other pairs. So I'm going to go ahead and list them for you now. We have also angle 3 and angle 7 are corresponding because they are below the line and to the right. We also have angle 1 and angle 5. And then we have angle 4 and angle 8 are all corresponding angles. Now, why are corresponding angles so important in parallel lines? Is because these angles are all going to be congruent. So all of these angles are congruent. They're congruent, which means they are equal measures, okay? So the next angle we want to talk about is we want to talk about our alternate interior angles. So this time we're still going to use the same pair of lines cut by the transversal P. Well, alternate means opposite. So we are going to look for angles that are on the opposite sides of the transversal. They're interior, so they're going to be inside our two parallel lines. Okay, so we want to look for opposite angles. So angles that are opposite the transversals and inside the parallel lines. So our very first alternate interior angles are 4 and 6. So we know angle 4 and angle 6 are alternate interior angles. So pause the video now and see if you can identify the other pair of alternate interior angles. Hopefully you paused the video and you were able to see that angle 3 and angle 5 are also alternate interior angles. Again, these angles are special because they are congruent. They are congruent, which means they have equal measures. Okay? Everybody good so far? So let's go on to our next angle, and we are going to look at alternate exterior angles. So this time we want to look at angles that are on the outside of our parallel lines and on opposite sides of the transversal. So my very first alternate exterior angle pair would be angle 1 and angle 7. Look at them. They're on the outside of M and they're on opposite sides of P. So we know that angle 1 and angle 7 are going to be alternate exterior angles. Pause the video here and see if you can find the other pair of alternate exterior angles. Hopefully you were able to find the next pair, which would be 2 and angle 8. These are my alternate exterior angles. Again, these angles are special because they are congruent. Okay? They are congruent, which means they are equal. So we can use that when we are finding angle measures. So let's get rid of this. Now, we are going to talk about same side interior angles. Now, same side interior angles, some teachers call them consecutive interior angles. It doesn't matter, they're both the same thing. Same side interior angles, in my opinion, is easier to remember, okay? Because that means they are on the same side of the transversal and they're inside the two parallel lines. So we can look at angle 4 and angle 5. Angle 4 and angle 5 are what we call same side interior angles or consecutive interior angles. Consecutive means they're side by side, okay? Interior means they're inside, so they're side by side, okay? I like the same side interior word because that kind of tells you it's on the same side, okay? So pause the video here and see if you can find the other set of same side interior angles. Welcome back. Hopefully you were able to identify that angle 3 and angle 6 are same side interior angles. Now, unlike the other three special angles that we talked about, these angles are not congruent. They are not congruent. They are supplementary, and that is very important. They are supplementary. So hopefully you know that supplementary angles are equal to 180 degrees. That means that the measure of angle 4 plus the measure of angle 5 is equal to 180 degrees. And the other pair too, measure of angle 3 and the measure of angle 6 is equal to 180 degrees. That is very important for us when we get back into the rest of our conversation. Okay? So let's put all these special angles to work and do a problem. Okay? So let's look at our problem here. Okay? In the figure, measure of angle 2, so we know the measure of angle 2 is 80 degrees. So using that one angle, we can do some magic and we can find all the measures of the other angles by just looking at that one angle. So let's find the measure of the other remaining angles, okay? So we know that angle 2 is an exterior angle, and we can find another angle that's an exterior angle, but on the opposite side. We call those alternate exterior angles. So angle 2 and angle 8 are alternate exterior angles, which means they are congruent. So we know that angle 8 has to be 80 degrees. See how we use that? Now, we can also use angle 2 again, and we can this time look at corresponding angles. So angle 2 is on top of M and to the right of P, of line P. So we want to go down to line N. We want to look for an angle that's on top, which is angle 6, and isn't 6 to the right of the transversal P? So we know that the measure of angle 6 is also going to be 80 degrees. Okay? Now, look at this. Angle 6 is an interior angle. It's on the right side of the transversal. So let's look at our alternate interior angles now. So now 6 is 80 degrees. 4 is alternate or on the opposite side of the transversal P. So we know they're opposite each other. So we know they're congruent because they're alternate interior angles. We know that angle 4 is also 80 degrees. Now, we're good with that, right? We can also check our answer because angle 4 is a consecutive angle to angle 8. So that means they're both 80 degrees. So we got it right. Now, I'm going to use something that I learned before, okay? Or I can also use my same side interior angles. So let's do same side interior angles. So we know that angle 6 is 80 degrees. We know that angle 3 is on the same side of that transversal. So because we know that 6 and 3 have to equal 180 degrees, so we know angle 3 plus angle 6 has to equal 180 degrees. We know that angle 6 is 80 degrees of that, so we need to know the measure of angle 3. So we have a little algebraic problem, so we're just going to subtract 180 degrees from both sides, and so the measure of angle 3 has to be 100 degrees. So we know angle 3 is 100 degrees. Now, because angle 3 and 5 are alternate interior angles, we know that 5 has to be 100 degrees. And because 5 is on top of N, we know that angle 1 is on top of N, M. They're also on the right side, so they are consecutive angles. So we know that angle 1 has to be 100 degrees. And because angle 1 is 180 degrees, angle 7 has to be 100 degrees because they are alternate exterior angles. So that is how we use these 4 angles to find measures of the different angles. So let's move on to example number 2. So why don't you pause the video now and see if you can do this one on your own. Welcome back. Hopefully you've done your work and paused the video and done this on your own. So let's do this real quick. So measure of angle 3 is 105 degrees. So we can find each one of these angles by just using that one angle, okay? So let's go. Well, let's look. I have 6 angles I need to find. You can do this one of 2 ways. You can go through all of the angles and find the angle measures and then go back and fill in the 6, but I'm not going to do that, okay? Now, one of my angles I need to find is the measure of angle 7. So we know that 7 and 3 are corresponding angles, which means that angle 3 and 7 are congruent, which means that angle 7 must be 105 degrees. 1 down, now we have 5 more to go, okay? So let's look to see if we can find any other ones that can help us with that. Well, look, we need angle 11. Now, if we magically could turn this around so that you could look at it a different way, can you see that angle 3 and angle 11 are also corresponding angles, which means that angle 11 has to be 105 degrees. Okay, so we're ready to go from there. Let's see if we can find any other ones just by using those two angles that were done there. Okay, so let's look. Angle 3, let's look. We have to find angle 5 now. Angle 5's position to angle 3 is their alternate interior angles. And because they're alternate interior angles, guess what? They must be congruent as well. So now we've got 3 of our angles down, okay? So now let's look. Oh, let's go to measure of angle 6. Well, we have a special relationship between 3 and 6. Angle 3 and 6 are same side interior angles, which means they have to be 180 degrees when you add them up. So we already know that angle 3 is 105. 180 degrees minus 105 gives us 75 degrees. So we know that the measure of angle 6 must be 75 degrees. Guess what? Let's look and see if we can go anywhere else. Look, angle 6 and angle 14 are what we call corresponding angles, aren't they? If we were able to turn this around so that you could look at it, you could see that they are corresponding angles. So angle 6 and angle 14 are corresponding angles, which means that angle 14 must be 75 degrees as well. Okay, now look at angle 11 and angle 15. They are corresponding as well. So they are going to be congruent, which means that angle 15 must be 105 degrees as well. Okay, everybody good? Okay, so let's go to our next problem. This time we are going to introduce algebra into this concept. And it's not going to change anything. We still need to know those 4 angles special angles in order to do that. I'm a very visual person, so I need to label things. So we know that the measure of angle 1 is 3x plus 15. We know the measure of angle 2 is 4x minus 5. We know the measure of angle 3 is going to be 5y. Okay, so our goal is to find the value of x and the value of y. So let's look at this picture and let's see. Angle 1 and angle 2 are what we call corresponding angles, aren't they? They're in the same position on the 2 lines. They're above line P and above line Q and on the right side of line R. So we know that if they're corresponding angles, they must be congruent, which means they must be equal. So we need to write an equation with these two equal. So we have 3x plus 15 equals 4x minus 5. We're going to subtract 3x from both sides, okay? And so we're left with 15 equals x minus 5. Now, if you're a teacher or you want to move your 4x, that's going to be fine with me. You're going to end up with a negative x and a negative number on the other side, and they just cancel each other and become positive, which is no big deal, okay? Now I need to isolate my x, so I'm going to add 5 to both sides, and so I get x equals 20. So we've solved for x. We now know x is 20. Well, let's look at our special relationship between 2 and 3. Again, 2 and 3 are corresponding angles. We know that they are equal to each other. They're congruent. Now we have a problem. So let's go ahead and write our equation. So we know that 4x minus 5 equals 5y. Right now we cannot solve this because we have two variables. But remember, we already found out what x equals in the previous problem, okay? So let's go ahead and substitute x into this equation and then go ahead and solve it. So 4 times 20 minus 5 equals 5y. 4 times 20 is 80. 80 minus 5 gives you 75, and that equals 5y. Let's go ahead and isolate y. So y equals 15. So we now know that x is equal to 20 and y is equal to 15. Okay, let's do one more example. Why don't you pause the video here and see if you can do this one on your own. Well, hopefully you paused the video and so that you can check your work with me and let's see what we did. So this time we have parallel lines cut by two transversals, and we call this a trapezoid if you want to. Okay, so we can do this one as well. So let's look. We need to find the variables in each figure, and we need to explain our reasoning. Well, we've got our parallel lines, and we know that they're cut by transversals. Well, let's look at this angle here, and let's look at this angle here. What is their special relationship? Well, they're parallel lines. They're inside their parallel lines. They're on the same side of this transversal, which means they're called same side interior angles. We know that same side interior angles, when added together, must equal 180 degrees. So we can go ahead and set up our equation. 15x plus 30 plus 10x equals 180 degrees. Go ahead and combine like terms. We get 25x plus 30 equals 180. Subtract 30 from both sides. We get 25x equals 150. Divide both sides by 25. And so we get x equals 6. Okay, so we know that x is equal to 6. And I kind of explained my reasoning to you by saying we could say this was same side interior angles. Okay? So let's find y this time. Again, y, these two angles here, let me change colors. These two angles here are on the same side and they're interior angles. So again, they're same side interior angles. So we can go ahead and do the same thing. We know that 3y plus 18 plus 90 equals 180 degrees. Okay, so we have 3y plus 108 equals 180 degrees. I can subtract 108 from both sides. And so I get 3y is equal to 72. I'm running out of room, so I'm going to come up here. 3y equals 72. Divide both sides by 3. So y equals 24. And again, same reason, same side interior angles. Now, the very last thing I want to do with you is we have a picture here. This time, our picture is incomplete. We have a problem. We don't have our transversals cutting both the parallel lines. So we can do what's called drawing an auxiliary line. So what I'm going to do is I'm going to draw an auxiliary line. I'm going to complete one of these transversals. You can complete either one you want, but I'm going to complete this one here. So I've got this one, I'm going to complete it here, and that's going to help me a lot. So why did I do that? Well, I want to create some numbers, or I want to create some relationships with that transversal that I know. So by continuing that auxiliary line, I can look at this angle here, okay? And I can look at this angle here, and they are what we call what? Can you think of what they are called? Okay, they are corresponding angles, aren't they? Because this one's on top of this angle, and to the right, this one's on top of this angle, and all corresponding angles have to be congruent. So we know that those two angles are congruent. Now, we have to pull on some prior knowledge that we know. We know that these two angles here are what we call a linear pair, which means linear pairs are supplementary, which also means that these two angles must be 180 degrees. So, well, if they're going to be 180 degrees, we know that this angle must be 80 degrees. Well, if you can see that we now have a triangle, okay? We've got a triangle here. And if you pull prior knowledge again, all triangles have to be 180 degrees, right? When you add up their three angles. Well, we have 80 degrees already. We have 50 degrees here, which gives me 130. So we know this third angle must be 50 degrees. Again, let's pull on some more prior knowledge. Look at this. We have another straight angle, right? Or a linear pair. Now, if this angle is 50, this angle's got to be 130 degrees. So we know that the measure of angle X has to be 130 degrees. Well, I hope you found this video to be informative. I'm sorry that it was a little long. If you did like this video, please subscribe to my channel and hit like. Thank you very much.